There is a problem that architecture has been solving for 3,200 years, and the solution has not changed in its essentials because the problem has not changed in its essentials. The problem is this: a space large enough to matter is usually too large to light from its edges. The windows in the side walls reach a certain height, cast light a certain distance, and stop. Everything beyond that distance, the center of the hall, the middle of the nave, the deep interior of the factory floor, falls into a permanent condition of obscurity that no number of candles or additional side windows can fully correct. The clerestory is the answer to this problem. It is a band of windows raised above the level of any adjacent obstruction, a lower roof, a flanking aisle, a neighboring volume, positioned precisely at the point where height creates the possibility of reach. Karnak Temple used it in 1250 BCE. Louis Kahn used it in 1972. The 22 centuries between them produced cathedrals, basilicas, factories, and museums, and every one of them, when the space was deep enough and the light problem acute enough, arrived at the same instrument. That is not coincidence. It is the most durable argument in the history of architectural section. The great Hypostyle Hall at Karnak is not a building in any sense that the word easily accommodates. It is a forest, 134 columns, covering a plan 102 meters long and 53 meters wide, the columns so closely spaced and so massive that the interior reads not as a room, but as a compressed stone landscape. The central nave pushes upward to 23 meters. The flanking aisles sit 9 meters lower, at 14, and in the gap between those two roof levels, cut into the stone at the highest point of the nave wall, are narrow slits. They are small, by almost any subsequent measure of the clerestory type. They do not flood the hall with light, but in a space that would otherwise receive no daylight at all. Bounded on all sides, covered entirely, the columns blocking any oblique penetration. They are the only source, and their position in section is exact. The height differential between nave and aisle is not a structural accident. It is the mechanism that makes the light apertures possible. The Egyptian builders understood, whether they formalized it or not, that in a sufficiently dense interior, light must be sought vertically, and that the section of the building must be organized to create the height difference from which vertical light can descend. The Romans took this section and turned it into a standard. The Basilica of Maxentius, completed in 312 CE on the north side of the Via Sacra in Rome, states the type with an authority that subsequent centuries would repeatedly borrow. A barrel-vaulted central nave, tall and broad, flanked by lower bays covered in groin vaults. The height differential between nave and flanking volumes opens a zone of wall above the lower roofline, and into that zone the builders inserted clerestory windows running the full length of the nave. Light enters high, travels downward, reaches the floor without obstruction from any adjacent structure. The section accomplishes what the plan cannot. It creates a path for light that moves clear of everything standing in its way. When Constantine's architects began converting this secular administrative type into the first major Christian basilicas, the original St. Peter's, the Lateran, the basilicas that would establish the template for 1,000 years of church building, they carried the section across wholesale. The clerestory came with the building. It was not a religious innovation. It was a practical inheritance that the new building program needed and did not have to invent. What Gothic engineering did was not invent the clerestory, but dissolve everything surrounding it. The pointed arch reduced outward thrust, the ribbed vault concentrated loads at discrete points. The flying buttress, that extraordinary external skeleton, carried whatever lateral force remained away from the nave wall entirely, transferring it down through the buttress pier to the ground outside. The wall, relieved of its structural obligations, could stop being a wall. At Chartres, begun in 1194 after fire destroyed an earlier building, the upper clerestory lancets reach approximately 7.5 meters tall, in a nave that climbs to 36.5 meters. The clerestory zone is no longer a row of slits cut into a thick stone wall. It is very nearly all glass, held in place by stone tracery refined to the minimum thickness structure permits. The logic of Gothic architecture, pointed arch, ribbed vault, flying buttress, is organized entirely around this ambition. The engineering does not produce the light condition as a byproduct. The light condition is the objective, and the engineering exists to serve it. The Clerestory at Chartres is not something the building contains. It is the reason the building was built the way it was built. The industrial Clerestory carries none of this ceremonial weight. At Saltaire Mills in Yorkshire, completed in 1853 for the textile manufacturer Titus Salt, the sawtooth Clerestory glazing running along the weaving floors has a single specific practical brief: deliver consistent diffuse daylight to workers operating looms across a floor too wide to light from its perimeter alone. The glazing faces north. Direct sunlight would create glare that interferes with fine cloth inspection. North light provides even illumination without variation through the hours of the working day. The Clerestory here is infrastructure in the most literal sense, a component of the production process, as functional as the spinning machinery below it. The height differential that at Karnak separated nave from aisle and at Chartres separated the nave arcade from the upper window zone is here the difference between the low-pitched roof over one workshop bay and the raised glazed panel set against it. Same section logic, entirely different context, zero ceremonial intention. The instrument operates without regard for what surrounds it. Louis Kahn arrived at the Kimbell Art Museum in Fort Worth in 1972 with a problem that was, in one sense, completely new and in another sense identical to every problem this essay has been describing. The 16 cycloid concrete vaults covering the museum galleries are each interrupted at their apex by a continuous skylight, a slot running the full length of the vault open to the sky. 3 inches below that opening, Kahn suspended a perforated aluminum reflector. Daylight enters the slot, strikes the reflector, splits, and distributes itself along the curved soffit of the vault in 2 directions, washing outward toward both sides of the space. Direct sun never reaches the floor or the walls. What reaches the floor and the walls is light that has been redirected, softened, made to travel along a surface before it enters the gallery. Kahn described this condition as luminous rather than lit, and the distinction matters. The space does not feel illuminated from above. It feels inhabited by light, as though the material of the ceiling itself were the source. The Clerestory, elevated to its maximum formal refinement, has become invisible. What remains is the quality it was always pursuing. The Clerestory is irreducibly a section decision. You cannot design it in plan because it does not exist in plan. It exists in the vertical relationship between 2 adjacent spaces, one higher than the other, and the aperture that occupies the gap between them. The plan shows you columns, walls, rooms. It shows you nothing about where the light comes from or how it travels. Only the section reveals that. The section is the drawing that shows you height, that shows you the difference between the nave and the aisle, the vault and the reflector, the low roof and the raised glazing panel beside it. Every architect who has ever solved the large interior lighting problem has solved it by reading their building in section and finding the height differential that the plan had not yet yielded. The Clerestory is what section thinking produces when the space is large enough and the need for light is serious enough.